Hello! Today, we're going to do an interesting experiment. We're going to investigate and look at life in action. Living organisms, just like us humans, need air to breathe and sources of energy enable to live. Like sources of energy, we meant water or food. Before we start, I would like to show you the materials needed in this experiment.
Print a glass diagram so that you can record which sugar solution is which. Glass, cling wrap, yeast, sugar, boiling water, cold water, and water at the body temperature.
In this experiment, we're going to use a very simple form of life, which is a baker's yeast. This is the single-celled kind of fungus. By giving air and food, it will grow and multiply. We're going to see which condition it likes the best.
Put sugar with the same amount in each glass. On the first glass, let's put cold water. And the second one, boiling water. And the last two, let's put water at the body temperature. And give them a quick stir after. Label the printed glass diagram. Let's put the same amount of yeast on each glass. Cover the last glass using a cling film to restrict the amount of air. Mark each glass. Five minutes have passed and you can see clearly that the yeast sprang into action and started to produce a foam. This foams the result of the yeast using the oxygen in the air to digest the sugar, and it's producing a gas as a waste or byproduct. In this particular case, it's carbon dioxide, and that's the process that makes the bread rise. To monitor the experiment and keep track of the process, we're going to measure the thickness of the foam and record how it changes over time. So that's 10 minutes up. The first one, the cold water, it seems that it just is starting to rise. The second one, the boiling water, doesn't seem to be doing very much at all. And these two, still doing really well and producing more foam. For the last time, measure the thickness of the foam and record it. Yeast undergoes aerobic respiration and uses oxygen to release the energy from the sugar, thereby producing water, gas, and energy in the form of ATP. As the volume of gas increases over time, foamy mass starts to form on the top of the liquid. This is an indicator of cell activity, particularly cellular respiration. The first glass, which contains the cold water, had a slow reaction rate. The low temperature contributed to the slow movement of the reacting particles, and this will affect their ability to catalyze the reaction. The second glass with boiling water has a slow reaction rate. When subject to a high temperature above the optimal range of the yeast, the enzyme involved in the yeast metabolism started to denature. This will stop or slow down the process, therefore decreasing production and metabolic rate. The third glass with water at body temperature has the highest respiration rate. Like most microbes, yeast has an optimal temperature range in which they can grow best. Since the body temperature is near the optimal temperature for yeast, which is 32 degrees to 35 degrees Celsius, it favors the reaction. Enzymes can work efficiently and food is oxidized, thereby releasing energy at a more rapid rate. And this has been Edselin Malayaw.